my name is Brandon, and I'm going to be showing you around the robot that we built for embedded systems. And here it is right here. Now this is our harvesting robot. It was designed to be used in a greenhouse, so it's a little on the smaller side. So if you compare normal harvesting machines like a combine harvester, you'd expect them to be massive. This one's a little on the smaller side. Also because it's kind of a proof of concept as well, because harvesting machines tend to be a little bit bigger than they need to. So I'll walk you through some of the components. So this silver box right here, this is our power supply. We decided to use a AC power supply to power the robot, as it was both cheaper and more reliable and simpler compared to a battery system, as well as since we know this is going to be used in a greenhouse, it's going to have access to it's going to have easy access to line power. So by using an AC power, and right now we just have it connected to an extension cord, but you can imagine a system where it will draw power from the rails it's riding on. So that leads into our little control box. If I pull the lid off the control box, you can see the circuitry we're using to control it. So here's the Arduino. That's running the program, and it's connected to, and it's running control signals into these 4 chips, and these are our motor drivers. And they look different, but they're the same type, even though the boards are different colors. And those are in charge of taking the control signal from the Arduino and outputting the voltage to drive the motors, because the motors take a voltage that the Arduino can't handle, so the motor drivers are in charge of handling that. They get their power from this distribution board, which splits the incoming one of the 3 incoming channels from the power supply into separate wires that go to each of the motor drivers, and we separate and then the other channel is going into this voltage controller, this voltage regulator. This voltage regulator is set to 5 volts, and that's being pumped directly into the Arduino, which allows the Arduino to operate on its own without any external connection to a laptop or something like that. And we can follow the motor cables. The motor cables come out, and they get split up to each of the 4 motors. We have 4 motors on this machine. They're all stepper motors, and we went with stepper motors because they are more precise and easy to control, and they mount a lot easier they have easier mounting options. And then here are our limit switches. We have one in the front and one in the back, and since the motors don't have encoders, so that's how we tell the robot to when it's reached the end of the rail, or when it's reached the boundaries, and so it doesn't run off the course. All right. So here's the robot as it's going through its harvesting technique. It's programmed to move forward a set distance for each row of crops, and then the rakes are supposed to flip upward, and any like potatoes or beets or any underground plants would get scooped up and set off, and by flipping it over, it would get laid out on the dirt. Now, unfortunately, with this machine in question, this showcases one of the main flaws with this implementation right now, which is that the motors lack a lot of power, and you can probably hear the motors as they're trying to actuate. The drive motors are moving forward, and the rake motors are trying their hardest to lift the rake up and then set it back down again, but unfortunately the rake is a little too heavy for them, and they don't have enough torque to actually do the movement. And I guess that's the downside with stepper motors, is that while we gain a lot with precision, we lose a lot in terms of power for the given amount of current.